look at graphing sine and cosine. This is one place where I am very picky. There are a lot of things that I allow you to show different amounts of work on. Some people show a lot of work, some people don't. And in graphing, I haven't really been picky about your scaling or the way that graphs look, but with graphing trig, I'm actually going to be very picky. So just do exactly what I do as we go through our examples, and I expect the same of the homework. When it comes to Friday's quiz, I don't grade it this way, but in theory, I should be able to just take a transparency of the answer key and lay it over top of everybody's quiz. Like, I want them to look that much alike, that they should all be following exactly the same course. Our graphs of sine and cosine are waves. They are periodic, which means that they do the same thing over and over and over, forever and ever and ever. They keep on following the same pattern. They're, we could also then say like cyclical. They do the same thing over and over. So we talked about last week how we could say anything that's cyclical, where you're doing the same thing over and over, could be modeled by trigonometry. So one of the examples that I gave was sunrise and sunset. So if I took sunrise times and plotted those, they would form this sort of a wave over the course of a year. That the sun rises earlier in parts of the year and later in other parts of the year, and it would follow this path throughout the course of a year. That we'd be able to plot a sine or a cosine graph from that. Music, a musical note. Music is created by sound waves. Waves look like these. So music notes can be modeled by trigonometric functions. And I'll give a lot of examples as we go through our problems of how those would relate to particular music notes. So in our graphs, there are three key features that we always need to consider. And the first is whether we're looking at a sine graph or a cosine graph, because they, although they look very similar, have one distinct difference about their shape. So for sine, what we do is consider the 5 key points of the function. And those will be the 5 points that we will graph every time. And so to describe what those 5 key points are doing, I would say that we have a point that's in the middle, and then a point that's up, middle, a point that's down, and then we end up back in the middle again as we cycle through those 5 points. So when I say what is the shape or the pattern of the graph, that's what I'm thinking of. What do those 5 points do? For cosine, once again, we'll consider 5 points to describe the shape or pattern, but cosine instead begins in the up position, then through the middle, the down position, middle, and ends up back in the up position. So when I say what is the shape of the graph or the pattern of the graph, that's what I'm thinking. So some students try to, make words out of those and I don't know, whatever. If that helps you remember it, I just think about middle down, middle up. I don't try to sound those out because I don't feel like they have enough vowels in them to really make words. But if that helps you, you may do that. The next thing that we're going to consider in our graph is called the amplitude. The amplitude is the height from the middle line. The amplitude is the height just strictly from the middle line. This is also the way that they measure waves in bodies of water as well. So on the news when they say that Lake Michigan has 4-foot waves, they don't mean from the bottom of one wave to the top of the next wave coming in. They mean like if the surface of the water was completely flat, how high is that wave above what the flat surface of the water would be? So the height of waves is always measured from center line to top peak. Okay? And the lower portion should always be the same. They're very symmetrical in that way. So that's our amplitude. And in our equation, that is going to be denoted by the letter A. And we'll look at those equations in just a moment. The third thing we'll need to consider when we're creating a graph is the period of the graph, or the length that it takes to go through that cycle of 5 points. And the period of the graph is given by 2 pi divided by b, where b is a letter in the equation that we'll look at in a moment. So the equation is the same whether it's sine or cosine. We just switch out which trig function we have. A, which we said is related to the amplitude, is a multiplier in front of the sine or the cosine. So if you have a number in the very front of the equation multiplied by the sine or the cosine, that is the amplitude. That determines the height of the curve. We said that our period was 2 pi divided by b. B is a multiplier that is right by the x. So if there's a number directly by the x, that number affects the period or the length of the graph. You may do your graphs on regular lined notebook paper, or you may do it on graph paper. So the way that I created the notes was kind of with the assumption that most of you will just do it on regular lined paper, but if you have graph paper, please feel free to use it. But I wanted to show you how to be specific and do things to scale on lined paper. So when we create our graphs, we're going to need our axes. We're going to create our y-axis close to our margin. And our x-axis I'll put right down the center of the lines that you're given here. Let's think about the 3 things that I said we need to consider about our graphs before we start putting any scaling marks onto these axes. So the first thing I said we need to consider is the shape of the graph. So this one is a sine graph. So sine graphs follow the pattern of middle up, middle down, middle. So when we plot 5 points, they're going to follow through that pattern. The second thing that I said we need to consider is the amplitude. The amplitude is the multiplier in front of the whole trig function. So in the very front of this equation, there's a 2. So that means this graph is going to have an amplitude or a height of 2. Then the period I said was given by 2 pi divided by b, where b is a multiplier in front of x. What's in front of x? 1, right? There's no number in front of x, so if there's no number there, it's like 1x. So this is just 2 pi divided by 1, or 2 pi. So it's going to take a length of 2 pi to go through those 5 points of the pattern. I want to always see 2 cycles of a graph, provided there's enough room on your paper to do that. Okay, so we'll get to a couple examples where there won't be quite enough room to do 2 full cycles. The directions in the book ask you to just give 1 cycle. I am asking you to give 2 cycles because I want you to see that this is a process that repeats itself. So if I need to see 2 full patterns, and it takes 2 pi to do 1 pattern, I need to measure out to 4 pi. And here's where I'm going to be very specific about the way we measure our graphs. How big is pi? What is pi? 3.14159, right? Pretty close to 3. Okay? Pi is right about around 3, if we're going to be a little approximate here. So what we're going to do is take each vertical line of the paper and say that it has a height of 1, and kind of use our fingers to pinch out what the height of 3 lines of our paper is, and tip it on its side, and call that length 3, or pi, since we're measuring our sideways things in terms of pi. So I'm going to take my fingers and just kind of pinch out 3 lines of my paper, tip them over, and call that pi. If you're using graph paper, then each box has a height of 1, and 3 boxes wide then would be where pi would belong. So graph paper will work just as well, a little better even, because then you don't have to do your finger pinch measurements, but you don't need to go out and buy graph paper for this. You can do it on lined paper. Just kind of pinch out 3 lines with your fingers, tip it on its side, and we'll call that pi. So if I need to fit in 2 cycles of this graph, I need to go out to 4 pi. And you don't need to use a ruler. I mean, just a finger pinch is good enough, and it doesn't need to be perfect, but I do want to keep this idea of an appropriate scaling there, where our x-axis is matching our y-axis. So So once we have our graph all scaled out, now we're ready to start plotting some points. When I plot points, I plot them in kind of what might feel like a strange order at first, but I think this is the easiest way to do it. I'm going to plot the first point first. Okay, that might not seem strange. So I'm going to put that little 1 under there to denote that the first thing I'm going to plot is the starting point, which is in the middle position, so that means it should be right at the origin.
Should that happen every time?
For sine, since sine begins in the middle, sine will always be at the origin. Cosine begins in the up position. Then this is where things might start to feel a little strange, but I do think this is the easiest way. The second point I'm going to plot is not the next point, but rather the very last point. So I'll put that 2 under there to show that this is the point that I'm graphing next. How long does it take to go through the full cycle of the 5 points? 2 pi. So that last point should be at a position of 2 pi, and since it's a middle point, that means it's going to be right on the axis. Now the reason why I kind of like to graph my bookends first is because since these graphs are so incredibly symmetrical, then I can break down everything by halves. So the next thing I'm going to do is plot what should be exactly in the center of those and put it right in the center of them. So I have my last middle point right in the middle, and then my ups and downs should come in the middle of those. So halfway between the first 2 points I have my up, and how do I know how far to go up?
2.
The amplitude is 2. So I have my up point halfway between up at a height of 2 and the down point halfway between down at a height of 2. So that creates one cycle of the 5 points. Now when you connect your dots, really concentrate on trying to make them curvy. Okay, they should be rounded, they should not be V's. Okay, no big points on these graphs. They should be nice and smooth curves. And I said I want to see 2 cycles, so then we repeat this pattern over one more time. Put arrows on the end to show that it does indeed go on forever. We did 2 cycles, but this thing does the same thing over and over and over forever. So in terms of music, what do you think the amplitude would represent? It is not pitch,
Volume.
it's the volume. Yep, the taller the graph, the louder it would be. So the taller the wave is, the louder the pitch would be. Or sorry, the louder the volume would be. And the shorter, then the quieter it would be. So using some music words, really tall graphs are going to be forte, really short graphs would be piano. What do you think the length or the period of the graph would do? The frequency or the pitch or the tone. The more stretched out it is, that would be like a slower vibration. So what kind of a note would that be? A low vibration. And if our graph gets really squished, so it's going through the cycle of 5 points fast, that would be a high-pitched note. You can think about kind of like the strings on a guitar. If you grab one of the skinny strings and pluck it, it vibrates much faster than if you grab the largest string on the guitar and pluck it. It has a much slower vibration. That would create a lower note than the faster vibration of the skinnier string. Okay. So you can kind of think about how those things would represent in music. Next example. First thing we consider, type of graph. This is cosine. Pattern for cosine is up, middle, down, middle, up. Second thing we consider is the amplitude. What's the amplitude for this graph? 1, because there's no multiplier in front of cosine. So the amplitude is a number in the very front of the equation, and there's no number there, so it's really an invisible 1. Period is always given by 2 pi divided by b, where b is what's with the x. So in this question, that would be 2, and 2 pi over 2 is pi. So when we go to create our graph, we'll create our axes the same way we did last time. But as we measure out, how far do I need to go? Just out to 2 pi, because I want to see 2 cycles, and if it takes pi to do 1 cycle, I need 2 pi. So grab 3 lines of the paper, turn it over, call it a pi, but this time we only need to go to 2 pi. And we'll fit the whole thing within that 2 pi. So this will be a faster moving graph than the last one. So in terms of music, this would be a higher pitch than the last one. To plot our points. The first point I plot is the first point of the pattern. So I'm going to plot the up. How high is it up? 1, because that's the amplitude. So right on the y-axis, it's up at a height of 1. Then I plot the final point of the pattern, which is up again to match the first one, at the length of the period. So at pi, it's up. Then I plot what's in the center of those. So the down, right in the center of those, down a height of 1. And then if I'm going to go from up to down, I must have to cross through the middles. So then we get the 2 middle points. When our graphs get squishier like this, a lot of times they do start to look more like V's, and that's totally understandable. Just really try to concentrate on having nice rounded edges instead of really pointy edges. I'm not going to be super picky about that, but if I see like V's, definite V's being drawn, I might be a little picky about that. Continue that pattern over one more time. And one thing to be careful of with cosine is when you do your little tails on the end to make your arrows, make sure that they're pointing down. A lot of students just want to continue that and have it heading straight on up because that's the way the line was heading, but it's never going to go up above those ups. Those ups are the highest it's ever going to be, so it must be turning downward to continue the pattern that way. So be careful about the little tails on your cosine graphs, that they're turning downward to continue the patterns. Questions? Okay, next one. Cosine. What's the pattern of cosine? Up, middle, down, middle, up. What will the amplitude of this be? 0.5 or 1/2. A multiplier in front affects the amplitude or the height. So in terms of music, this would be really soft. The shorter it gets, the softer it is. And the period is 2 pi divided by b, which is what in here? B is 1, so we just get 2 pi. So that means then, when I go to create my axes, I will need to measure this one out to 4 pi. To plot points, I'm going to plot that up point first, and it's just up 1/2. Plot my last up at the length of the period, so above 2 pi, up 1/2. And in the center of those, the down, a down 1/2. Make sure your down amplitude is matching your up amplitude. And in the centers of those, we need our middle points to cross over. Then repeat that pattern over the next 2 pi. Questions?
How again do you know what to put for B?
B is the multiplier in front of the x. So a number that's right in front of the x. And if there's no number in front of the x, then it's just like there's an invisible 1 there.
Oh, okay.
All right, our next one is sine. What's the pattern for sine? Middle up, middle down, middle. What's the amplitude of this graph? 1. There's no multiplier in front of the trig function, so it's like 1 there. The period is going to be 2 pi divided by what? One half, or 0.5. How do I divide by a half? Multiply by 2. So I then get a period of 4 pi for this one. On your paper, I believe you have enough room to go out to 8 pi. I, however, do not. So I'm just going to draw in one cycle of this one. And if you would like to just draw one cycle as well, you may do that. So on your homework, I want to see 2 cycles if 2 will fit. So again, I think on your paper, 2 would have fit fine here. But on mine, I just don't have enough room. So then I would just do 1 cycle here. And you can use that same kind of rule on your homework. If it fits, do 2. If it doesn't fit, then just do 1. So then to plot our points, since this is sine, we're going to start in the middle, which means we start right at the origin. After 1 period, so that's 4 pi in this one, we have that final of the 5 points, which is a middle. Then we have the point that's right in the center of the pattern, which is a middle. Between those first 2 middles, we have our up with an amplitude of 1. And then, likewise on the other side, down with an amplitude of 1. Questions?
Basically, the dots will be over or on each pi.
For this one, yes. The dots end up at each pi. So far in our problems, we've only adjusted one thing or the other. This problem will adjust both the amplitude and the period. Cosine, what's the pattern for cosine? Up, middle, down, middle, up. What's the amplitude of this graph? 1/3. This is going to be a very short graph. Okay, in terms of music, this would be very quiet. The period is 2 pi divided by b. What is b in this problem? Pi. What's 2 pi over pi? Just 2. So what that means is our period or our length measurement does not involve pi in this problem. So when I go to do my scaling here, I don't really care where pi is because that doesn't have anything to do with my question. My question, I need to know where 2 is. So what we're going to do is the same type of idea, saying that each line of a paper has a height of 1. So I could still take 3 lines and tip it over, but instead of calling it pi, I'm going to call it 3. Or take 1 line of a paper and tip it over so that every 1 line would create a width of 1. Okay, so that we're getting that nice even scaling. But we don't care where pi is here because our period doesn't have a pi in it. Okay, so if you're using graph paper, each box would have a height of 1 and a width of 1 here, since we don't care where pi is.
How many do we do?
2 cycles. So I went out to 4. Yeah, we could fit tons more, but you only need to do 2.
You have a really, really small period, and then you can't fit all, like it's hard to fit all of those ways.
Yeah, if your period gets like way too squishy and you feel like you're having trouble plotting all those points in there, you could kind of stretch out your scaling. We're going to look at in the next example how we could kind of shrink our scaling, so you could use kind of the reverse idea there as well. As long as you're consistent that if your y scaling changes, your x scaling has to change too. I want them to change together. So for this one, I'm going to do my first point up. It's only at a height of 1/3 though. So on this one, I wouldn't really want to scale my y's any different with it just being 1/3 there. Definitely wouldn't want to shrink that down. Suppose we could stretch it out a little bit though. Then the up above 2, since that's the length of the period, again at 1/3. The down at 1/3, and right in the centers. So in music, this would be very quiet and pretty high pitched because it's pretty squishy sideways too. And repeat the pattern over once more. And again, with cosine, be careful that when you hit those endpoints, you're rounding back down for your tails and arrows. Questions? Last example, cosine. So our shape is up, middle, down, middle, up. Amplitude, 2. Period is 2 pi divided by, we always want to think of what x is being multiplied by. So x is being multiplied by 1/4 here. We could write that same thing as 1/4 times x. We always want to think of the multiplication that's happening. B is always the multiplier. So we're going to divide by 1/4. What's the same as dividing by 4? Or rather, dividing by 1/4 is multiplying by 4. So we get 8 pi. I can't fit 8 pi on my paper. I think you could on yours. You definitely can't fit 16 though. So this is a case where just 1 cycle would be sufficient. But I need to adjust my scaling because I'm not going to be able to fit this. And you have to fit at least 1 cycle. We don't just want to do partials. So I'm going to put my y-axis in here, put my x-axis in here. And you may adjust your scaling as long as you adjust them symmetrically. So what I'm going to do is say that every line of my paper, instead of being 1, is a height of 2. Then when I take 3 lines and tip it over, instead of making 1 pi, it makes 2 pi. Okay. So you may adjust your scaling one way or the other. If you wanted to count by 1/2 on that last question, that would be fine. But then you would have to tip over 6 lines of paper to make a pi. Okay? So you may adjust your scaling as long as you adjust both. To plot our points then, since this is cosine, it starts in the up position, which is a height of 2, but be careful of our scaling. That's really only up 1 line. At the end of the period, which is 8 pi, it's up at a height of 2 again, which is 1 line since we changed our scaling. In the center we have our down, and in the center of those we have our middles. So this would definitely be a base note. It's a very long cycle length. It was also a little bit louder. We changed our scaling, but it did have a height of 2, so the volume was up a little bit on this. Questions?
Wait, how do you know where to put the dots?
I do my first point right on the axis, and then I do the bookend point, so I did the very last point of the cycle. What would be the last up point? And then everything cuts into the middle of that. So then I did the central point, and then I did the points in the middle of those. So it should always be symmetrical, that everything is breaking down halfway. Your homework is from 14.1.